Hello there, Nareg is here. Today I'm going to solve the first exercise of session 2016, the first session, chemistry, an exercise which is related to atoms. So let's start. Ionic compounds and molecular compounds. In nature, ionic compounds are solids. They are characterized by their rigid structure. They have higher boiling and melting point temperatures than those of molecular compounds. This is due to the strong electrostatic force of attraction between the ions in ionic compound. The table below represents the boiling and melting point temperatures for some ionic and molecular compounds at a given pressure. So, regarding this table, we have the compound which is methane, sodium chloride, water, magnesium oxide, and the melting point temperature, the boiling point temperature for each one. The Lewis electron dot structure of hydrogen sulfide molecule H2S is given as we have H linked with two bonds to two atoms of hydrogen. Refer to the above table and text. Pick out the reason why ionic compounds have higher melting points. So from the table, we can already find out that sodium chloride and magnesium oxide, they have a high melting point of 800 and 2800, boiling point 1400 and 3600. And from the text, we can see that this melting temperature and boiling temperature are high because this is due to the strong electrostatic force of attraction between the ions and ionic compound. List the ionic compounds. The ionic compounds are sodium chloride and magnesium oxide. These are the two ionic compounds. Refer to the Lewis electron dot structure of hydrogen sulfide molecule. Indicate the type of bond between the sulfur atom and each of the hydrogen atoms in H2S molecule. Justify. So, we know that hydrogen will make only covalent bond. So, in this case, we have a single covalent bond between hydrogen and one electron of sulfur, and another covalent bond between hydrogen and the sulfur again. So, we will form two single covalent bonds between S and the two hydrogens. Verify that the element sulfur belongs to group 6 or column 16 in the periodic table. So for the sulfur, actually, as you can see, it is entering into covalent single bonds. So it has two celebratory electrons. This Lewis representation of sulfur will be S double point. So once we count the number of electrons, it will be 6, 2 plus 2 plus 2, 6. So 6 valence electrons. So since sulfur has 6 valence electrons, it will belong to group 6 or column 16 in the periodic table. The electron configuration of potassium atom is K2L8M8N1. Potassium reacts with sulfur to produce the compound potassium sulfide K2S. Explain the bond formation in the compound potassium sulfide. So in order to form this, actually what's happening is that potassium has one valence electron. Of course, we have two potassium atoms in this case with in front of one sulfur. As for sulfur, since it has 6 valence electrons, it has a tendency to gain 2 electrons in order to obey the octet rule. As for potassium, it has a tendency to lose that electron, the valence electron, in order to obey the rule or the octet rule. So K will be transformed to K plus, S will be transformed to S2 minus. There will be a mutual attraction between them, and they will form an ionic bond. So this is how the bond is formed in this compound. The boiling point temperature of the compound hydrogen sulfide is minus 66 degrees Celsius. Choose among the propositions given below the one that corresponds to the boiling point temperature of potassium sulfide. So, potassium sulfide is an ionic compound. It will have a boiling or melting point which is higher than minus 66 degrees. So, equals to no, less than no, so it will be higher than minus 66 degrees. This was all for this first exercise, session 1, 2016 chemistry. I hope it was helpful. I'm going to ask you to subscribe to my channel because I'll be uploading new material. I'll be solving new sessions, so you'll be notified. And I can also share with you my Instagram and Facebook account in case you want to contact me, or you can simply leave a comment below. That's all for this time, and see you later.